with image processing principles. Okay, basically whenever you open any image and you keep zooming it, this is homogeneous, so let me take a different image here. So whenever you open any image and you try to zoom this, you'll get to understand how the image is composed of. Okay, basically any image is composed of pixels. Okay, image is digital image is a sample version of an analog image where the overall area is divided into equispaced grids, and each grid or each pixel is represented by a color. Okay, now how do we perceive this image? So once we get that image into paint and we try to zoom this image, in the paint also we'll be able to visualize the pixels. Okay, so this is where each pixel is all about. Now paint has a color selection tool. If you select any specific color with a color selection tool and then you call for edit color, you'll be able to see that the image is, this pixel is represented by three values: red, green and blue. So any color can be represented by combination of red, green and blue. Say if I make red as 255, green as 0 and blue as 0, this will be purely red color. Instead of 255, if I make it 120, it will be still bit reddish. Green, if I vary, it will be a different color. So in this way, color combination will vary based on the values of red, green and blue. And red, green and blue's values are restricted between 0 to 255. That means 1 byte of data. Okay, and this data does not have any sign, so 0 to 255 unsigned data, which means that each pixel is represented basically by three color components. One is red component, one is green component, one is blue component. These are also called the channels of the images. So each image is composed of three channels distinctively. One is a red channel, green channel and the blue channel. Now you take any specific color. When you click on edit color, you'll see that any color can be formed by some combination of red, green and blue. So if I make green and blue is equal to 0, that becomes a purely red image. Okay. Now if I make green as 255, the other thing I make as 0, that becomes a green image. So by varying the values of red, green and blue, you can clearly see that the data cursor, okay, I can move it. So any color can be formed by the combination. When you start with image processing in Matlab, say when you start with image processing, you can read any image with the imread command. We know that in Matlab we use single quotation to use strings. Okay, so imread, file name of the image that you want to read. Matlab has got several images. Matlab gives you several images which are present in toolbox images directory. One of the very common images is cameraman. Once you read the image into a variable, you can display the image using imshow command. Now a few things to be noted here is that any image visually is a two-dimensional object. Okay, it will be having some x values, some y values, and x and y will represent a particular pixel. Each pixel will be of again r, g and b times. Okay, so whenever you read any color image in Matlab, okay, you'll be getting a three-dimensional array. First two dimension row into column, and the third dimension is for colors. One for red, one for green, one for blue. So suppose an image is of size 256 by 256, then the matrix that you are going to be scanning is of 256 into 256 into 3. First component will be all red values, second component will be all green values, third component is all blue values. Now, images can not only be color image type, the images can be also of grayscale type. We shall first see one simple example of an image here in Matlab. So, whenever you read the image, you'll get the figure window like this. This also you can zoom, just like you zoomed it in thing. Matlab has a data cursor. You can click on data cursor, place on any pixel. It is going to give you the value. X is 102, Y is 76. Here you'll see something that index is 220. What is this index? If you observe this image very carefully, there is no color component. This image looks, which we in common terms we call a black and white image. This is not a black and white image. This is technically known as a grayscale image, because these values will be varying from the black to white. Black being represented by 0, white being represented by 255. Anything in between will be different shades of grayscale. Okay, so this is how the image is. Now in Matlab, when you try to go to workspace, you'll see here that image is represented by 256 into 256 size. If you open this, you'll see the pixel values. The values will be between 0 to 255. If you call minimum of IM, minimum value is near about 0, that is 7. If you call max of IM, around 255. So all the values will be between 0 to 255. Now in ideal cases, we always want to read the image from the user. Okay, we would not want to work with Matlab images. Rather, for every project we'll be having our own set of images. Okay, so how do we work with this? It's always advisable, when we code a script, we use CLC, clear all and close all. Close all will be removing the previous windows. Clear all will wipe out the workspace variable, and CLC will clear the command prompt screen. Now, in order to whenever we try to select some existing file, we do this by file open dialog box. Okay, so whenever I want to select some images or files, anything from any software, I'd be always going for a file open dialog box. So with respect to each software, a file open dialog box will be provided. This is the file open dialog box. Just like any other software, Matlab also provides a file open dialog box. You can do this, and this dialog box will return two output variables. Okay, first is the file name, second is the directory name. Say for example, if from file open dialog box you select this image in the desktop, say Koala. Okay, Koala. So this Koala image, if you click on properties, its directory is C drive, uses Rupam desktop, and its name is koala.jpg. So file name will be returned in koala.jpg, directory name will be returned in C drive, uses Rupam desktop. If you combine both of them, you will get absolute file name, C drive, users Rupam desktop, koala.jpg. So let us get on with the coding. We can do this. Start.jpg is the pattern. Okay, if you want user to select PNG images, you can give start.png, and this is the method that we will be giving. For opening any file, I require the total file name. So I already know that we can concatenate the directory name with the file name just by calling stringcat method. So in the path C drive users Rupam will be there, in the file name koala.jpg will be there. Both of them combined together, the whole file name will become C drive users Rupam desktop koala.jpg. Matlab is going to open this file, and then in image read I am going to pass file name. Things to be noted here is that, look, I would not be passing file name in single quotation. Why? Then file name itself, then the string value itself will become file name. The string is file name. Here f name is a variable. So instead of passing file name in single quotation, I would have to pass the variable name, because if I pass string, then Matlab will assume that your image name itself is f name. Okay. So instead of doing that, we will just pass the file name and let us display the image. So once you run, you select any image, Matlab is going to display the image. Now let us zoom a specific area of the image in order to see the pixels. Okay, so these are the pixels. Now if you take a data cursor and click on this, in this case you will see not index values but rather RGB values. Red is 204, green is 183, blue is 164. This is more or less grayscale. Now let me select a region which is quite black. So if I select this region which is quite black, if I click on any pixel which looks quite black, you will see all the RGB values will be near to 0. RGB values are nearer to 0. On the contrary, if I select a region which is relatively white, you will see all the RGB values will be nearer to 255. So this is how Matlab is going to handle the images. Now coming back to the image array, once you look at this IM, you will see that the matrix is 768 into 1024 into 3. That means 768 rows, 1024 columns, and each pixel being represented by 3 colors. Okay. See, one of the common operation, look, in normal cases different images will be of different sizes. Okay. Now for most of the image processing algorithm, it is very important that images be of the same size. Okay. If you calculate certain statistics on the image, two different type of images, if they are of the same size, you will get homogeneous statistics. See, if you take the average of marks of only 2 students of the class, that will be completely different from another class's average if you take that average over 50 students. Okay. So whatever algorithm is, it generally assumes that the images that you are working with, okay, this images is of same size. Okay. So how do we resize the images? Matlab gives you a command called im resize. Using im resize, can resize any image. So image earlier will be scanned to 768 into 1024. We are going to convert it to size 256 by 256. I do not have to specify 3 explicitly over here. If it is a color image, Matlab will keep the color component. If it is a grayscale image, it will be leaving the grayscale image. So you need to specify number of rows and columns that you want the image to be resized to. When you execute this and when you run this, you will see this image which will be ideally quite smaller, and when you look at this image variable over here, the size of the image is 256 into 256 into 3. Right. Now let us try to understand one fact. Say, when you talk about the images, we have seen that each pixel is represented by some values of red, some values of green, some values of blue. But how these values are displayed. So what happens is it assumes more or less like a photographic plate. Okay, it assumes that first plate is of red color. Okay, so whatever percentage is, it is going to mark red with those percentage. Then Matlab is going to assume that the second plate is of green color. So it is going to put the shade as per its value, and the third plate is of blue color. So all this color will be superimposed, that is cascaded, and that is the view which you get. Okay. So because these three color components are superimposed, okay, we can actually separate the color components. These are called channel extraction. Okay. So let us understand how we do color channel extraction. Combination of red, green and blue. So this kind of images are known as RGB image. Again, if you take a data cursor and click on any part of the image, you'll see that over here for x is equal to 44 and y is equal to 103. The RGB value is 227, 1, 2, which means the value of red is 227, the value of green is 1, the value of blue is 2. On the contrary, if you click on bit of green portion, you'll see that the green part is more than the red and the blue part. Now, analyzing the image here, you'll clearly see that the image data type is 207 into 244 into 3. This is a 3-channel image. That means each pixel is now represented by 3 components. First is the R component, then is the green component, then is the blue component. This kind of images are also known as 3-channel image. The first image that we saw, grayscale image, that is also called as single channel image. Okay, number of colors that defines an image will be known as the channel of the image. Okay, now so you can clearly see this image is formed by 3 channels. Okay, one is red component, one is green component, one is blue component. So you can say that this image is formed by superimposing 3 different channel values, right? So what if you could extract the 3 channels? What is the result? Let us see that. So let me say that IMR is equal to IM. Let me try to extract the grayscale, extract the red component. Okay, so for all the rows, all the columns, I want to make green and blue component 0. Okay, what would I have to do? 2 to 3 should be 0. I have first assigned my image into IMR. So IMR is nothing but the original image. In this original image, the green and blue channel is being made 0. Okay, let us try to you can clearly see that in the red component, okay, this is almost similar to the main image. You can clearly see that the red part is almost similar over here, and this is more or less dark in the other end. Now what if I try to extract the green channel? Let me say IMG is equal to IM, and then I need to make red and blue as 0. So what would I have to do? Okay, green I have to leave out. So 1 in the sets of 2. Okay, so after 1 the next value will be 3, which will be made as 0. Let us say green channel image. Now because the rose part is not being, green is not attributing anything to the rose part. When you take the green channel, okay, you'll almost see a void at the center. Let us see this. See, now it becomes quite clearer, right? Okay. Similarly, we can also extract the blue channel. Okay. So for blue channel, it is going to be 1 and 2, which should be made as 0. Now, you are working with retina signal processing. Retina has got a very good property. I should show you with one of the retina images. So see, because this leaf part was mainly the major leaf part, this was mainly attributed by green channel. Okay, so green channel is quite significant across the border. Okay, and this was not purely green. Okay, this is a light green with shades of blue. Okay, so this is how we can actually separate the channel. When you process the retina image, okay, retina image has got a wonderful property. If you separate the green channel, you know, here the veins are much more prominent. Okay, so this is in many of the retina paper, this is one of the most common pre-processing state. That is, you need to, you know, separate out the green channel. As soon as you separate out the green channel, with respect to green channel, this becomes much more significant, okay, than the other channel. This is how, this is where the color segmentation. If you look at the blue channel, okay, this is almost, you cannot see the veins, but veins are most clear in the case of green channel. Okay, so if you read about certain literature in retina signal processing, this is one of the most major important steps. Now, right now, see, most of the image processing papers that we see, you'll see the images in grayscale. Okay, there is a concept associated with this. Okay, in image processing, we say that if a theorem is proved for a n cross n matrix, that theorem is proved for n cross k matrix also. That means if certain filters or certain mathematics can be applied in a single channel, that can also be applied in n number of channels. Okay, so many of the image processing algorithms are developed and tested in the grayscale images. Okay, therefore we should know a method of converting the color image into grayscale image. Okay, and one of the common ways of doing it is, in Matlab there is a command called RGB to gray. If we call RGB to gray, we can convert any image into grayscale image. Okay, now, so let us say IM gray so using Matlab is equal to RGB to gray IM, and let me display this. So this is the grayscale version of the image. If you call RGB to gray, the image gets converted into grayscale. When you look at the workspace, it will be quite clear that the grayscale is 207 into 244, only one channel, whereas IMG, B, IM all are 3 channels. Okay. Now, look, the grayscale images are also known as intensity images. Okay. Why it is known as intensity images? See, an image is formed when light forms on an object, okay, and gets reflected back. So the object whichever color it is going to basically absorb all the colors other than the colors that it is made up of. So therefore, when the light falls on the object, only that specific color gets reflected, color band gets reflected. Okay. Now color is again made up of 7 different colors. Out of them, the red color has the maximum intensity. Okay. A grayscale image is said to be representing the illumination. That means if a light fall on a surface, how glowing that surface would look like. Okay, so if you look at this grayscale image, you can see that this is a bit darker. Okay, so we can say, so this kind of images are also known as intensity images. As far as physics is concerned, the light bands, in all the light bands, red has got the maximum intensity or the energy. Okay, so most part of the image is being formed by the red channel. Now, taking the physics concept into consideration, we can convert any image into grayscale image simply by separating the green and blue channel. Okay, and just taking the red channel. In earlier case, what we have done is we have not separated. We have kept all the 3 channels but made green and blue as 0. Okay, see all these images, IMG, IMB, IMR, all are 3 channel. You know, N cross 3. So I have all the 3 channels, but 2 of the channels are 0, so they are not contributing. But we can actually convert any image into grayscale simply by extracting the red channel. Okay, how? So let us say IM gray using red channel is equal to IN of colon comma 1. See, look, the difference here is that IM is comprising of 3 channels. I'm just copying the first channel and putting it into the other. Green and blue we are leaving out. We are not making it 0. We are leaving out totally. So obviously the result will be only a single channel because 2 of the channels are left out. Let us look at this image now. This was the grayscale image that Matlab converted, and this is the grayscale image which is obtained by taking the red channel only. Another major thing that you can see by looking at both these images is red channel image is much more brighter than the other image. That is simply because red channel will always have maximum energy contributing to an image. Okay, no matter whatever the image is, even the images of green grass, red channel will be much more significant. Okay, this is the Matlab conversion and this is the conversion. So even if it is purely looking green, your red channel image is never going to be black. It will be having the maximum energy. So actually the intensity will be always contributed by the red channel. Now coming back, how do we perceive any equation in Matlab? Okay, how do we basically implement the equations in image processing in Matlab? So RGB to gray actually implements a formula. Okay, let us see that formula. If we click over there on RGB to gray, and if I say F1, you can clearly see that RGB can be converted by using this formula: 0.29 into red plus 0.58 into green plus 0.11 into blue. Okay, so if we are to implement this formula, then so using the formula, let us say this is gray conversion by Matlab. Gray conversion by color channel extraction, and let us say gray using formula. So this is basically the formula. Okay, how do we apply this kind of equation? So in your paper also you will have several equation. How do we go about applying the equation? We'll take one image, say I am gray, formula. This is saying the red channel. Okay, red channel is represented by this is represented by, and this is represented by okay. Now see what happens here is okay, I'll put this and let me say I am a formula image by now. Can you look at these two images? This was converted by Matlab. This is done by using the formula. Okay, so we can take any image processing formula and we can apply it in this fashion. Okay, now see what I want to do is I want to make some little changes. What I want to do is those values, okay, of the images which are little less darker, I want to make them 0. Okay, I want to make the most brighter stuff more prominent. I want to make the background entirely 0. Okay, so such kind of a thing is known as thresholding. We can apply the thresholding without using any for loop, simply using this technique. So say I am gray now see the thresholding, how it works in Matlab is you need to use a find command. Okay, so I'm trying to find all the pixels where grayscale value is less than 150, and for all these pixels I am gray of all these pixels, I'm going to make it as 0. Okay, so this is like a equation saying I am gray is equal to 1 where pixel values are greater than, you have seen such equations. Okay, I am gray is equal to some value if pixels values are greater than 0 otherwise. Okay, so we are making that formula. I'll explain you the reason for doing this. Okay, I am gray in gray image by for thresholding. Now okay, less than 150, or we'll say less than 50 is greater than 0. We are just able to convert this image. Okay, we are getting the grayscale. Now why I should use this is, by theory any formula which is applicable to grayscale is also applicable to color images, right? How? Now if I am to replace this, my image value will be IM, right? Okay, but this formula was for one channel. So how am I going to work with this? I am going to work with this in this fashion. First, for I is equal to 1, 2, 3, there is all the three channels. Some temporary image is equal to IM of colon comma I. So as I value is 1, first I'll be extracting red channel, green channel, blue channel, in that way. We'll extract one channel, apply the theory into that specific channel, okay, and then IM of colon comma I will be 10. So what we are going to do is, first we'll take one channel, apply the formula into that channel, replace it back into the original image. So lastly I should have displayed IM. Okay, so whatever algorithm we develop for image processing, we can first apply it on the grayscale. If we get the result, then just use a simple for loop for 3 channels, apply the algorithm independently on 3 channels, and then replace the original channel value with the filter value. Now why there is a difference between these two images is because in the color channel values will be little different. So if you change the threshold, they'll be able to see quite a difference in this one. Okay, this is one of the method of segmentation. Okay, so if we do some thresholding, certain colors will be completely eliminated. We'll be getting the region of interest. This is also known as region of interest. Okay. Lastly, in image processing, whenever we are trying to show so many images, it gets very difficult to keep on checking. You might be having 300 images and just opening all the window then closing, that gets difficult. So always use a subplot. Subplot is an option in Matlab by means of which Matlab allows you to draw as many images in a single figure. So suppose this is the figure where now you are seeing one image, okay, one figure each in every image. Instead of that, you can actually divide a single figure. Say divide it into 4 parts. Okay, so this figure will be known as 2, 2 rows, 2 columns. Out of them, when you want to display the image here, it will be 2, 2, 1. When you want to display the image here, 2, 2, 2. Similarly, 2, 2, 3 and 2, 2, 4. So let me say subplot 3, 3, 1. It should be done with subplot. Okay. Now I should not use a figure here. Figure means it should come into the next figure window. Instead of that, I should use subplot. This is the second image. Then again I should use a third. This is the third image. Again, instead of figure, I should use a subplot. This is the fourth image, fifth image, sixth image, seventh image. Finally, let me have this as 8th image. So when you run, you'll be able to see multiple images into the same figure window. So analyzing becomes easier. If it was colored image, what happens when you extract the red, how it looks when you extract the green, blue, gray, etc. So using subplot